Hi, it's Mrs. Cat, and I'm here to look at the first 4 problems on Unit 6, Worksheet 2. And this is where we're going to be representing ions and formula units of ionic compounds. Now, right now, we are only going to be focusing on the particle diagrams for the ions and formula units, as well as writing a chemical formula if one is not given to us. So you are not going to name yet because, whoops, you don't know how to do that. Okay, so I guess you can't see that on the screen, but don't do the names yet. We're also only going to look at numbers 1 through 10 to start out with, do a little bit with naming and formula writing, and then you'll go on to finish 11 through 15. We'll come back and do the names for 1 through 10. Okay, aside from having this page either digitally or just having it in front of you, a hard copy, or using your own piece of paper, which may be just as easy. You're also going to want your periodic table with ions. Now, I have a hard copy of it. This is linked like everywhere, a bunch of places. It should be linked in this assignment as well. This is going to be super important because we're going to use this bottom half of this page now where we have our periodic table of ions. Okay, so what we have in this first example for number 1 is we already have particles drawn for our calcium +2 ion and our bromine -1 ions. Okay, we also have this already combined into a formula unit, which is going to be our neutral compound. So what we want to start out by doing is writing the formula for this compound. Now, what I want you to notice is the way that this is written and listed for all of our ions is that we have our positive cation first and our negative anion second. And that is always going to be the order that we write them in when we write our chemical formulas. Okay, so what we're going to do is we're just going to write out what we have. Okay, these are all there in order to give this compound overall a neutral charge of 0. So I have 1 calcium +2 ion. So I'm going to write that in there. Okay, I have 2 bromine ions. So I'm going to represent that by putting a subscript of 2 after the bromine. Okay, that's our chemical formula, right? Now, if we go the opposite direction, not really the opposite direction, but we've got a little less information on number 2, we have a list of ions, right? We know we're going to use iron +2, and we're going to use chlorine -1. So what we want to do is we want to draw particle diagrams to show that we have these ions. Okay, so the way that we're going to do this for the purpose of this activity is we're just going to kind of recreate what we already have as our example from number 1, in that our particles are going to be different colors, and they're going to include the charge of the ion on the inside. So I'm going to use orange for iron +2. I'm going to use green for chlorine -1. Okay, now, right now I have +2 and -1. That still is a positive charge, so I'm going to need another negative chlorine ion. Okay, let me make that negative sign actually look like a negative sign, not a slash. So I'm going to have 1 iron +2, 2 chlorine -1s. And so to make my formula unit, I want to combine those so that they are attached, showing that they form a compound. Okay, and then I can go back to write that formula. Just like we did in number 1, metal comes first, non-metal comes second, or, okay, more generally, cation comes first, that's positive, anion comes second. So this is going to be Fe, just 1 ion, Cl, 2 ions. Okay, FeCl2. Now, what we have when we get to ones like number 3 looks a little crazy, okay, but what we have is called a polyatomic ion. Okay, so let me highlight one of these. Okay, we can see the particle diagram. Okay, we can see the formula there. Let's see, what color should I use here? Something bright. Let's go with red. Okay, polyatomic ion. Okay, I'm going to erase that in a second so I've got space for my formula. But polyatomic means just what you think it is. It has many atoms. So a polyatomic ion is going to be a group of atoms where the whole group of atoms has a charge. What we do when we represent this formula, okay, is we put that group of atoms together and we still put that charge up in the top right-hand corner. What we're going to do when we draw our particle diagrams is we're going to put our group of atoms together as our particle diagram. We're going to put a dashed circle around the outside and still put our charge on the inside. That's going to show that the whole group of atoms together is what is going to have that charge, whatever it may be. In this case, we have this SO4 2-, and that whole thing is going to have a -2 charge. Now, I'm going to go ahead and erase this polyatomic ion here, or the word polyatomic ion, as well as my highlighting. Okay, now we can see, just like example number 1, we have all of the pieces of the particle diagrams that we need. Okay, we've got potassium, which is +1. There's 2 of those. Okay, with the SO4 2-, that's called the sulfate ion. Okay, you can find that name on your periodic table of ions at the bottom. And that's got a -2 charge. So we're going to see that this formula unit contains 1 sulfate and 2 positive potassiums. So now what we'll do to write that formula, potassium has 2 ions, so we're going to put the 2 after that. Okay, and then the SO4, there's only 1, so that's going to follow directly. Okay, if you only have 1 polyatomic ion, you're just going to write it as is. Okay, we'll see in our last example, which is number 4, that if we have more than 1 of a polyatomic ion, we're going to need to do a little something different when we write the formula. Okay, so what we've got in number 4 is an aluminum +3 ion. I'm going to start out by drawing that. I'm going to choose a different color. Let's go with red. Okay. And then I have this NO3 -1 ion. Now, the name of this is nitrate. That's not particularly important right now. Okay, nitrate. But you can find that on your periodic table of ions. But what is important is how we're going to draw this. So what I'm going to do is I'm going to draw N with 3 O's on it. Okay. So it doesn't really matter how you do it, but I'm going to go solid in the middle and white circles around the outside just because it's simple and it matches the one that's already there. Okay, then I'm going to put my little dash circle around the outside of that. And then somewhere inside of my circle, I want to show that that whole thing has a -1 charge. Okay, so +3, I need a total of -3 to make this neutral. So I'm going to need to draw 2 more of those nitrate ions. So exactly the same. I'm going to need a total of 4 atoms, 1 N and 3 O's, and then somewhere in there put a negative sign. Okay. Hopefully I'm going to give myself enough space. Got to get a little creative sometimes. There's my minus sign. Okay. My formula unit picture needs to show this all combined together. So we want to put our positive charge here. Now we know at this point about what happens when positive and negative charges interact. Okay, we should know that a positive charge is going to be attracted to a negative charge. Okay, but positive charges repel other positive charges. Negative charges repel other negative charges. So when we draw our particle diagrams, we want to make sure that any positive and negative charges are going to be touching one another. If you have more than 1 positive charge or more than 1 negative charged ion in your formula, keep them as far away from each other as possible in your picture because that's what's going to actually happen. They're going to repel and stay as far away from each other as they can. So I'm just going to kind of put my 3 nitrate ions kind of, in a little triangle around this. And I'm going to actually draw my circles for those ions first, give myself a little space, and then I can go back in and draw in the individual atoms. Whoops, that wound up being a little too small. Okay. And then I don't want to forget to put in my negative charges, right? Last thing I need to do is write my formula. Now, looks like I crowded my space a little bit. Okay. Now, you notice that some of these are taking up a fair amount of space, especially with these polyatomic ions. If this spacing on this physical page isn't going to work for you, just do it on your own piece of paper. Okay, when you submit it, I want to see that you have your formulas for your ions, okay, your formula for your formula unit for your compound, and then you have the particle diagrams for each of those pieces. As long as you have that somewhere, I don't care whether it's on a hard copy that's from this page, if it's your own paper, if it's a digital file, it doesn't matter to me. And it won't matter to your own teacher if you're not in my class. Okay, so this time, aluminum, 1 ion, nitrate, 3 ions. The problem with this is if I write this out the same way, okay, there's 1 Al, 3 NO3s. If I show that this way, and the way that I would have written it before with just a regular monatomic ion, the problem is that now it looks like I have an aluminum, a nitrogen, and 33 oxygens, which is not the case. So to solve the problem, what we need to do in our formula is put the nitrate ion formula in parentheses and then put our 3 to represent 3 nitrates on the outside. Okay, now, if we are going to find the molar mass of something like this, remember that the 3 on the outside is going to need to be distributed inside as well. So really, this is saying we have 3 times 3 oxygens and 3 times 1 nitrogen, right? Which is what we can see in our particle diagram. Okay, so now at this point, you've got numbers 5 through 10 that you're going to complete. Submit that. I'll take a look at it, or your own teacher will take a look at it. We'll figure out how to name and write some formulas, and you'll go back and do 11 through 15. Please make sure if you have any questions on this as you're completing these particle diagrams, ion diagrams, and the formulas that go along with them, that you reach out to your respective teachers so that they can help you. Please don't sit there struggling and confused when it's going to be just as quick and easy to reach out to your teacher for a little bit of help.